Hi guys, so we're still in chapter 7. We're working with simultaneous equations and we are on lesson 3. In lessons 1 and 2, we learned 2 ways for solving certain pairs of equations in 2 variables. So we either add or subtract the equations from each other to produce a third equation. And the magic about that third equation is it only contains one variable. Sometimes, though, life is not that simple. Sometimes, when we add or subtract those equations, we still end up with, dun da da da, you guessed it, 2 variables. This happens when the original equations contain different numbers of x's and y's. So, what's a person to do? Never fear, multiplication is here. So looking at this cartoon, we can see that PJ's sister is probably a middle child because she is feeling duped. But we know PJ's mom would never shortchange her sweet, precious angel. As we see, their mom gave each of them one whole sandwich. She cut one sandwich into 2 pieces. It's still one sandwich, but she cut it into 2 pieces and gave her daughter the 2 out of the 2 pieces of the one sandwich. For PJ, she took one sandwich. She cut it into 2 pieces, and then she cut each of those 2 pieces again to make 4 pieces. So it looks like this. We take the first half and the second, and we multiply it by 2, and we get 4 out of 4 pieces. But it's still just one sandwich. Okay, well, we can do this with equations too. As long as we multiply all the numbers in the equation by the same multiplier, we really haven't added or taken away from the value. We just are expressing it a little bit differently, like PJ's mom did. So in this equation, if I multiply, looking at that distributive property, everything it's still equal. So this lesson, that is all we're doing. This lesson, that's all we're doing. And there's a couple ways we can do it. The first way is just to pick one equation and multiply it by a number that's going to give us the same number of either x's or y's as the other equation. So looking at this one, we could multiply this equation by 3 so that we have 3 y's in both equations. Well, we could do that. Or we can multiply this equation by 2 so that we have the same number of x's as the equation above. Well, let's do that one. So if I multiply everything in the equation by 2, I come up with, if I do my math right, 4x plus 6y equals 48. Now, let's bring this equation down. 4x plus y equals 28. Okay, now, do I add or subtract these two equations? Well, of course, I'm going to subtract so I can eliminate one of the variables, the one that's with the 4. So we're going to subtract. That makes that 0. And 6 minus 1y is 5y. And 48 minus 28 is 20. Not done yet. Y is not by itself. Divide both sides by 5. Y equals 4. So we don't know x yet, and y is 4. And then from there, we will plug 4, or our y, into one of these equations and solve for x. And then we will plug both x and y coordinates in both equations and make sure we have the right answer. Okay, so I plugged y into the top equation, and as you can see, we subtracted 4 to both sides, and that left us with 4x equals 24, divided 4 on both sides, and we solved for x, that x is equal to 6. 6 and 4. So now we just plug it in to both equations and make sure that both sides are equal in each equation. Okay, and the magic math fairy came and checked for us. And yes, those are the correct coordinates. And remember that the coordinates mean that on a line graph, the top equation has its own line, is a linear equation. So is the bottom one. And so they will intersect or meet at the coordinates 6 and 4. And on a quadrant, that would be in the plus plus. So x is plus, y is plus, so it's in the second quadrant. Okay, this is in the problem sets in lesson 7.3. It's number 10. And here we have 8x minus 3y equals 32, and 7x plus 9y equals 28. So we can see that both equations have different numbers of x and different numbers of y. So we're going to pick one and multiply it out to make one of those have the same number. I'm going to choose that one. I'm going to multiply that whole equation by 3. And then I should end up with 9y for both equations. Okay, so I brought down, after I multiplied out by 3, the top equation ended up 24x minus 9y equals 96. Then I bring down the second equation, and we're ready to solve. Now we have a negative 9 and a positive 9. So do we add or subtract the equations? We will add them. And that will give us 31x, these cancel out, is equal to 124. Get rid of that 31 on that side of the equation. What we do to one side, we have to do the other. And so we divide, and x is equal to 31 into 124 is 4. Okay, so we just plug x. Okay, so we just plug x back into the one of the equations to solve for y. So I chose the top equation, and I plugged 4 into our x, and right now I'm at the part where we are at 8 times 4 is 32, minus 3y equals 32. And when we subtract both sides, we get 0 on the right, and we get negative 3y on the left. So we divide by negative 3, divide, and y equals 0. So now all we have to do, as we always do, is plug both values into both equations and make sure they are equal. Okay, so the magic math elves came again and plugged in both values, and yes indeed, both equations worked out just fine. Okay, but there's all kinds of ways that we can solve simultaneous equations. We don't always have to just manipulate as the first step just one of the equations. Sometimes we could go ahead and add and subtract both the equations and come up with an answer. Let me show you what I'm talking about. This is on page 303 of the book, and it's a cartoon where a gentleman is writing all over the walls trying to figure out this set of simultaneous equations. So let's see how we could solve for it if we did a couple of things. The first thing is let's add both of these equations together, because I noticed that 55 plus 45 is 100, and 45 plus 55 is 100, and that makes, for me, a lot easier to manipulate numbers when they're tens or hundreds. So I added the two together, and we got 100x plus 100y equals 1,000. Then I did the next step, which is I subtracted the two equations, and that's right here. And when you subtract them, you get 10x minus 10y equals 40. Now, what I can do is take that bottom equation, and I can tell that it's going to be really easy to make that 100. So I'm going to come down here and multiply that bottom equation by 10. And when I do, let's make sure I put my right letters in there, please, and thank you very much. Okay. When I do, I get 100x minus 100y equals 400. Now, I'm going to take that, and let's see where we go. I'm going to plug it in to the equation of 100x plus 100y equals 1,000, which is when I added both those equations first. Okay? So when I do that, I get 200x. The y's cancel out, and then I add the 1,000 to the 400, and I get 1,400. And if we divide 200 to this side, 200 to this side, we get x equals 7. Really? Yes, really. So now all we have to do is solve for y. So we pick one of the equations and plug x into it, and let's see what we get. Okay, so I picked the bottom equation. I plugged 7 into it and multiplied out. 700 plus 100y equals 1,000, and we'll just finish that up. We'll subtract 7 to get it to the other side, and that will give us 300 equals 100y. Divide 100 to both sides. and we have y equals 3. So our coordinate were those two crazy numbers, crazy equations that form lines, so they're linear equations. This is where they will meet on the graph at 7 and 3. And you need to plug those in to both equations and make sure that they are equal. So it looks kind of scary, but it's actually kind of fun. It's like one of those puzzles. And the poor guy on page 303, he wrote all over his wall, and we didn't need a wall to solve that problem. So that's what this lesson is all about. It's just changing expressions without really changing value in order to eliminate one of the variables, so we can then solve for them, just like we've been doing in lessons 1 and 2. But we're just adding a step ahead where we may have to massage or manipulate one of the equations, or add and subtract both of them and create two different equations where they both have can be worked out easier. I hope that helps, and I will see you guys later. Bye.